Adaptability and innovation are the key to navigate the ever-evolving landscape of Indian power sector. As we embark on the journey towards a Viksit Bharat at 2047, challenges may abound, but within them lies a seed of opportunity for a brighter and more sustainable future. With this perspective, I, Dr. Shimi Sudalata, on behalf of the Electrical Engineering Fraternity of Punjab Engineering College, deemed to be University Chandigarh, extend a warm welcome to you all in this inaugural ceremony of this 3-day workshop on emerging developments, challenges and opportunities ahead in Indian power sector for a Viksit Bharat at 2047, organized during 21st to 23rd February 2024 by the Electrical Engineering Department, Punjab Engineering College, deemed to be University Chandigarh. We are especially thankful to our chief guest, Mr. Manoj Tripathi, Chairman BBMB, and our invited speaker for the first session, Professor S.P. Singh, Professor HAG, Electrical Engineering Department, IIT Roorkee, who has joined us to dignify and magnify our event despite their busy schedules. We are honored to have in our midst Professor Baldev Setia, our esteemed director, whose unwavering support has been instrumental in shaping the success of this event. We are feeling privileged to have Professor Rintu Khanna, Head Electrical Engineering Department, without whom who has been a strong pillar of support to this event. We have with us Dr. Manohar Singh, the workshop coordinator, and Dr. Ajay Kumar, the co-coordinator, whose visionary insight was a driving force behind the inception of this event. We are delighted to have with us deans, HODs, faculty, staff, finally all our active participants from the power utilities of Haryana, Punjab, Himachal and Chandigarh, then the technical education department participants and other industries who have all joined us today, without whom this event wouldn't have materialized. Once again, I welcome you all to this power sector conclave. Now may I request Professor Rintu Khanna to welcome our esteemed guest, Engineer Manoj Tripathi, Chairman BBMP, with a plant which symbolizes the potential for growth and prosperity. Now I request Professor Rintu Khanna to welcome our worthy director, Professor Baldev Setia, with a plant. Now may I request Professor Manohar Singh, the workshop coordinator, to welcome Professor S.P. Singh from IIT Roorkee. We begin this function with a beautiful tradition that symbolizes the essence of light, knowledge and prosperity. The lighting of the lamp signifies the illumination of our hearts and mind, the dispelling of ignorance and the invocation of auspicious energies. I request our dignitaries to kindle the auspicious lamp and embark on today's proceedings.
या जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश.
The Electrical Engineering Department at PEC has a rich legacy of excellence, innovation, and academic rigor. Our commitment to pushing the boundaries of knowledge and fostering a culture of research and innovation is unwavering. Ladies and gentlemen, it is my great pleasure. I would like to call upon Professor Rintu Khanna, Head Electrical Engineering Department, to enlighten us with valuable insight into a remarkable journey of Electrical Engineering Department at PEC.
Very good morning to all. I feel honored to welcome respected Chief Guest, Shri Manoj Tripathi ji, Chairman BVMB, our worthy Director, Professor Baldev Sethia ji, invited speaker, Professor S.P. Singh from IIT Roorkee, all deans and head of the departments present here, faculty members, executives from power utilities, participants, staff, and students for gracing the inaugural session of 3-day workshop on emerging development, challenges and opportunities ahead in Indian power sector for Viksit Bharat at the rate 2047. The Department of Electrical Engineering at PEC Chandigarh is dedicated to become an internationally recognized center of excellence in academics, research and technological services in the area of electrical engineering and related interdisciplinary fields. This is one of the oldest departments of the institute and has well qualified and mature faculty working for the continuous enhancement of research and teaching environment. The department offers Bachelor of Technology in Electrical Engineering and 2 programs at post-graduation level, one in Electrical Engineering and one in Electrical Energy System. Moreover, the department also offers PhD program to carry out the research in various domains related to electrical engineering. Currently, PhD scholars are working in the areas of smart grid, renewable energy integration, electrical vehicle technology, energy efficiency, power converter design, image processing, biomedical engineering, and development of new architecture for neural networks, etc. Now, several research facilities are available in the department. These are such as OpenRT real-time simulation, ETAB, MicroLab box, DSpace, DStatCom, Wind emulator, Solar PV emulator, different digital controllers, and microgrid setup with solar, wind, battery, and supercapacitor. In recent past, several research grants have been received from DSP, AICT, SCRB, TQIP to strengthen the research facilities and infrastructure. The department has also MOUs with Mitsubishi, Tata Power, Punjab Energy Development Agency, and many IITs. The plan of the department is also to establish a new state-of-art research laboratory to augment all the available research facilities under one roof for the further strengthening the research outcome. It is also being planned to establish a new center of excellence for power and energy management to augment research, testing and consultancy in the areas of renewable energy integration, vehicular technologies, microgrid planning, operation and remote wide area control, demand side management, etc. And also to foster the exchange of ideas between industry, academia across India. Now the focus of the research and development facilities at the Center of Excellence will be for the continuous development of the country to support the Viksit Bharat at the rate 2047. Now, our department's distinguished alumnus has immensely contributed in different domains of electrical engineering. Now, a few of them are Engineer Ravindra Kumar Tyagi, 1987 batch, presently Chairman and Managing Director of Power and Grid Corporation of India Limited. Engineer Rajiv Gupta, Director Projects of Engineers India Limited of 1985 batch, and distinguished academician Professor Chanan Singh in Texas A&M, USA. So in the meantime, department is keen to organize short-term courses, workshops, conferences in the fast-growing field of these electrical vehicle technology and renewable energy integration in the coming time. Now, in view of this, the department is the joint organizer of 5th IEEE Indian Council International Subsection Conference, IndisCon 2024 from 22nd August to 24th August 2024. The purpose of this 3-day workshop is also to share the knowledge, expertise, and discuss the sustainable energy development, its challenges and opportunities in India power sector among experts, executives in power utilities, and academicians for continuous development of the country. Definitely all the sessions of workshop will be very interactive and fruitful for all the participants. Looking forward for your active participation and also long-term association with electrical engineering of PEP. Thanks to all and warm welcome.
Thank you, ma'am. As electrons flow through the veins of a modern power system filled with sustainable energy sources, they carry not just electricity, but the aspirations and ambitions of the globally interconnected society. It is indeed an honor and privilege for me to call upon Dr. Manohar Singh, Associate Professor, Electrical Engineering Department, who is also the event coordinator, to throw some light on the objectives and purpose of this 3-day workshop.
Thank you, Dr. Shemi, for inviting me. Good morning and the greetings of the day. Respected Chief Guest Shri Manoj Tripathi, Chairman, Bhakra Abhyas Management, Chandigarh, Professor Baldev Setia, Worthy Director, Punjab Engineering College, Professor S.P. Singh, IIT Roorkee, Professor Rintu Khanna, Head of Electrical Engineering Department, Dr. Ajay Kumar, Assistant Professor, Electrical Engineering Department and Co-Coordinator of this event, distinguished guests, Deputy Director, Deans, HODs, faculty members, executives from the different power utilities, staff, research scholars, and the dear students. As in coordinator of this workshop, I extend a warm welcome to one and all for attending the inaugural session of the 3-day workshop on emerging developments, challenges, opportunity ahead in Indian power sector for Viksit Bharat by 2047 from today onwards. As we are well aware, energy sector is passing through a transition to make the future energy from the sustainable and the green energy generating resources. Indian power sector is extensively planning to increase the share of the green power in its total installed capacity. These renewable resources are highly localized in India. The transportation of the renewable power over long distances has a huge bearing on Indian grid operation and control issues. Power sector is preparing its roadmap to cater new emerging electric demands from the e-mobility transport sector, in addition to its traditional demand from the industry, commercial, domestic, and the agri sectors. In view of this, it is projected that Indian energy sector will face a compounding growth in line with the national GDP, and expected energy demand will be close to 9,000 to 1,000 gigawatt by 2047, which will be around 3.5 to 4 times of its present demand of 220 gigawatt. This would then account around 90% of clean energy, and India can achieve the power independence through its energy security policy in real sense. At Electrical Engineering Department of PEC, we are working with a vision to set up a power research center to cater the technical requirements of the power utilities in the northern India. As a humble beginning in this direction, we have called this 3-day workshop to deliberate and understand the emerging requirement and the challenges of power organization of the northern India, so that we can work in collaboration with the power utilities and the researcher for the Viksit Bharat by 2047 vision launched by the Honorable Prime Minister of India, Shri Narendra Modi. This workshop will focus on the exploring the new research in the renewable integration, challenges of the hydro power, interaction of the thermal power with the renewable energy storage, grid operational and the control challenges in planned 500 gigawatt integration by 2030 and beyond. Your participation and support in this workshop would greatly contribute its success and enhance our collective efforts toward addressing and the evolving needs of Indian power sector. We have received around 30 registered delegates, participants from the various power departments, 10 engineers from the Punjab Electricity Board, 9 engineers from the Haryana Power Generation Corporation, 5 engineers from the Bharat Vyas Management Board, Chandigarh, 3 from the Renewable Energy Science and Technology Department, Crest, Chandigarh, 2 from the Punjab Energy Development Agency, 3 from the Himachal Transmission Power Corporation, and 6 from the various academic institute of Haryana Technical Education Department, and few more from the Chandigarh Electricity and other academic and the research institute here local. During this workshop, experts are invited from the different domains of the power engineering to share their view on the emerging challenges of Indian power sector. On day one, Dr. Ishan Saran, Chief Engineer CA Ministry of Power Government of India, is joining us in the afternoon session to share the future plan of Ministry of Power on the planning of the Indian transmission infrastructure to host the emerging power demand of the 500 gigawatt renewable. Professor S.P. Singh from IIT Roorkee is already with us to deliberate on the planning, challenges and the future of the hydro potential in India as a sustainable power generation resource. On day 2, Professor Sonal Tange from IIT Roorkee will deliberate on the urban waste to energy potential, challenges and future in India. Dr. Ravi Sagar, a leading power system expert from the GE, will deliver a technical session on the grid operation and the control issues in hosting the renewable integration. In the afternoon session of day 2, we have invited Professor Sukumar Mishra from IIT Delhi to deliberate on the emerging research in the microgrid operation and the control. A panel discussion has been scheduled on the role of the thermal generation in view of the increasing renewable penetration in the grid. This session will be chaired by a senior officer from the NTPC. So on the day 3, the technical session on the challenges, opportunity and the reform in the Indian distribution system will be delivered by Rajiv Sapra, an expert from the Delhi Transco Limited. Dr. Kuldeep Rana, scientist E from the Ministry of New and Renewable Energy, will join us to share the policy document and the government roadmap for the clean and the green energy. A technical session on the role of the academic institute in shaping the Indian power sector by 2047 has also been scheduled. Another technical session on the security constraint, economic dispatch and the grid ancillary services in India will be delivered by Shri Fani Shankar Chilukuri, Chief Manager, Grid Controller of India Limited, on the last day. In this way, 10 different technical sessions have been scheduled to cover the important topics of the power sector in highly time-optimized schedule. Regular tea and the lunch breaks are scheduled between the sessions for the convenience of the participant. The venue for the technical session is the new academic block. A group of the volunteers will help them to locate the venue and other important locations in the institute. I express my heartfelt gratitude to the Chairman BBMB for sparing his valuable time to grace the event as an inaugural chief guest. I would also like to express my sincere thanks to worthy Director Shri Baldev Setia for his guidance and the motivation in planning and sparing his valuable time for presiding this event. My special thanks to our invited speaker, Professor S.P. Singh for IIT Roorkee, for joining in this inaugural session. I express my sincere thanks to Professor Rintu Khanna for her tireless effort to bring this event in this shape. I also thank Dr. Ajay Kumar, Assistant Professor, who is a co-coordinator with me in planning and coordinating this event. I would like to thank all the speakers who readily accepted our invitation to deliver the technical session during this workshop. I would like to express a profound gratitude to the BBMB, Punjab Electricity Board, HPTCL, Crest, PEDA, HPPTCL, Chandigarh Electricity Department, Haryana Technical Education Department, and other power utilities and academic and the research institute for open-heartedly nominating the executives, faculty, and the research scholar for this program. I offer my special thanks to Dr. Shimi Asser, Associate Professor, Electrical Engineering Department, for coordinating this session. I also thank the students for their voluntary work during this event. At the end, I would like to thank each and everyone present in this hall and sparing their valuable time for making this event vibrant through their active and the cheerful presence. Thank you very much.
you, sir. PEC's journey started more than a century ago, and now it has established itself as one of the premium institute of Northern region. Let's have a glance of PEC's legacy through a short video.
Welcome to the Odyssey of Punjab Engineering College. Situated at the foothills of Shivalik, the legacy of this 149 acres of sprawling green campus dates back to 100 years. Founded as the Mughalpura Technical College in Lahore by the then Lieutenant Governor of Punjab, Sir Edward Douglas McLagan, post-independence, the institution transitioned to East Punjab Engineering College to IIT Roorkee. It was in 1953 that they shifted to Chandigarh as Punjab Engineering College and were recognized as deemed to be university in 2003. Decade by decade, PEC evolved into the magnanimous institution that it is today. Throughout its journey, PEC has played an instrumental role in the nation-building process and is the alma mater to many illustrious individuals like Padma Vibhushan Satish Dhawan, astronaut Kalpana Chawla, the first woman of Indian origin to explore outer space. She was awarded the Congressional Medal of Honor. Padma Bhushan and comic Mr. Jaspal Bhatti set in front of the world a new paradigm of comedy. Punjab Engineering College has been blessed with visionary leaders such as Dr. H.C. Singh, Dr. S.R. Mehra, and Dr. R.N. Dogra, who have paved the way to the institution's remarkable legacy. Our director, Dr. Baldev Setia, is currently holding the baton to help the institute strive and achieve greater excellence and carry forward the rich centenary legacy. On November 16, 2021, a historic day unfolded with the esteemed presence of former President Sri Ramnath Kovind, gracing us with his presence to preside over the celebration of the completion of 100 years. During this momentous occasion, he generously gifted our institute the Centenary Hall, Centenary Gate, and Semiconductor Research Center. The following year, on 9th of October 2022, the Honorable President of India, Srimati Draupadi Murmu, graced our institution with her presence. On 52nd convocation and closing ceremony, the epitome of 100 years of superiority, she served as an inspiration. The foundation stone for the new hostel extension of Kurukshetra Boys Hostel was laid by Sri Rajnath Singh. Punjab Engineering College has been a pioneer in encouraging technical growth. The faculty and students at the institute have been actively involved in conducting international and national conferences, short-term courses, expert lectures, hackathons, and competitions covering today's emerging standalone technologies. PEC has been selected in the first cohort of 30 institutions of India with a funding of 85 lakhs under the Semiconductor Mission of India. Furthermore, to strengthen the institution's academic and research initiatives and to promote industry interactions, MOUs have been signed with other top institutions like IIT Roorkee, IIT Mandi, NIT Uttarakhand, International Center for AI, Cybersecurity Research and Innovations Taiwan, SSPL Delhi, RCOEM Fortis Hospital, PGI, and UT Police. Punjab Engineering College prides itself on its contribution towards society through various events. The celebrations included a G20 S20 event, Engineers Day, Yoga Day, a blood donation camp, Teachers Day, and World Environment Day, all received with tremendous enthusiasm. Expressing patriotic fervor and aligning with the National Azadi Ka Amrit Mahotsav initiative, the festivities encompass various events such as Republic Day, celebrating Independence Day with grandeur and joy, and commemorating the Chandrayaan landing. PEC has consistently aimed for the comprehensive growth of its students who exhibit proficient skills across a wide spectrum of cultural, technical, and extracurricular activities. These activities included orientation for the new batch, athletic meets, alumni meets, and Pet Fest, an extravaganza of talent and hard work. Punjab Engineering College relentlessly works and strives to contribute to the development and progress of the nation. We, as an institution, hope to continue to be symbolic to India's commitment to its diversity and innovation and contribute to the glory of the nation.
It is both an honor and privilege to introduce to you a visionary leader, a man of distinction, Professor Baldev Setia. Before joining to the post of Director, Punjab Engineering College deemed to be University Chandigarh, he has been serving as professor in the Department of Civil Engineering of NIT Kurukshetra, India since 2006. He has more than 35 years of experience in teaching, research, consultancy and administration. A graduate of civil engineer in 1985 and a postgraduate of water resource engineering in 1992, both from the Regional Engineering College Kurukshetra, now the NIT Kurukshetra. He was awarded his PhD by IIT Kanpur in 1998. Dr. Setia has held important positions including that of as a director of AICTE, New Delhi, the principal of Maharishi Markandeshwar Engineering College, Mulana, and nodal officer of IIIT Sonipat, which has been mentioned, which was mentored by NIT Kurukshetra. He has published more than 170 research papers in international and Indian journals and conferences, including 4 patents protected under the Intellectual Property Right India. He has visited USA, UK, Australia, Spain, Iran and Japan for attending international conferences. It is my honor now to invite our Director Sir to address our participants with his words of wisdom and encouragement.
Honorable Shri Manoj Tripathi ji, Chairman Bharat Vyas Management Board, and our chief guest for the inaugural ceremony of this 3-day workshop. Professor S.P. Singh, our invited speaker from IIT Roorkee, Professor Rintu Khanna, Head Electrical Engineering Department, Dr. Manohar Singh, Dr. Ajay Kumar, coordinators of this workshop, deans, heads of various departments, esteemed members of the faculty, Shri Vinay Gupta, Director HRD BBMB, Engineer Amod Jindal, Chief Engineer HPGCL, participants of this workshop, students, ladies and gentlemen. Well, I'm indeed very happy and feel honored to be standing here before you and addressing this august gathering. I'm indeed honored by this. I take this opportunity on behalf of the Institute, on behalf of the organizers of this program, and on my own behalf to welcome our chief guest, Shri Tripathi ji, as chief guest of this function to the portals of this institute. So you're welcome to the institute. I also take this opportunity to welcome Professor S.P. Singh from IIT Roorkee, other distinguished guests, and participants who have come from the neighboring states of Punjab, Haryana, and other organizations. Well, at the same time, I would come forward to compliment the department through the head and the coordinators. I would like to compliment and congratulate the department for having initiated and materialized this wonderful workshop on the topic of emerging trends, emerging development, challenges and opportunities ahead in Indian power sector for Viksit Bharat at 2047. So the very first word, or the word challenge, I believe there are too many challenges in this topic itself. The great part that the department has taken this initiative to tackle such problems is a welcome step, and I compliment the department for this initiative. Well, I have been listening to the coordinator when he stated all these words in the title itself. Well, regarding power, I believe, or the energy, I believe the 4 A's that normally come to the mind are the availability of power, the accessibility of power, the acceptability of power, and then the accountability of this entire system. I believe this workshop will be handling all these points, all these issues through these A's, and certainly that's going to be very beneficial. Well, regarding the further importance of the energy sector, I believe that in general, not only India, but the world over, we are going to face problems of energy, and that energy which is clean, green energy. In general, we say that for the future we require energy, we require clean environment, and we require strong computing machines, computing tools. Those are going to be the requirements of the future. So whatever kind of energy we produce, whatever way we produce, I think environment is going to be a very, very major and serious factor in this. Long back, I was associated with one consultancy problem of one of the power plants, or the first power plant in the state of Haryana, PTPS, and Mr. Amod Jindal, who is here with us today, he will be corroborating or endorsing my views on that. A power plant that was producing power by thermal. Thermal means it was Panipat Thermal Power Station, named in different ways at different times. But something that I want to put before you is that, in fact, that was a lifeline of power generation in Haryana. Something that I realized when I visited that plant, I found that the plant was suffering from problems more than one, n number of problems. But the underlying statement was that it has to run 24 hours of the day, and it has to run for 7 days of the week. We just cannot afford to stop it. The power supply to the thermal power station was flawed. It was full of problems. It was being taken from one canal, what we call as the daily parallel branch, and it had to be conveyed over a distance of more than or close to 5 kilometers. And then the major issue for which we had involved immediately, for immediate attention, was the problems being faced by an adjoining village by the name of Kokrana. Thermal power stations, most of us have sufficient idea about it, but those of you who have not visited any thermal power station, I would suggest, be it any branch that you belong to, but if you get an opportunity, kindly visit one thermal power station and realize the kind of challenges they are facing. At that time, this power plant, PTPS, it was facing the major problem of ash dye, the ash that is being generated by burning of the coal. Two types of ashes that they are producing. One of them is the fly ash. Because it flies, it's called as fly ash. There's no control over it. And huge mounds of fly ash are being produced when we generate electricity. How to handle those? That was the major challenge. Initially, when the plant was established, maybe they did not realize this problem, or something somewhere got amiss, and the mound which started getting erected, the mound which actually started getting in place, it did not have any impermeable layer put on the ground. that was the mistake or error or blunder, inadvertently or otherwise, that happened long, long back. And because it was a lifeline of power generation for the state of Haryana, every development was associated with energy, and the energy was coming from this major single source. And when we visited this about 10 years back, that mound had got up to a height of close to 16 meters. Come to think of it, 16 meters. And the area that it was occupying at that stage was about more than 1,000 acres. Well, again, 1,000 acres, it's easier said than imagined. Our campus here is 150 acres, slightly lesser than 150 acres. So more than 6 PECs, an area equivalent to that, standing up to a height of 16 meters, and so much of fly ash in the form of slurry, fly ash and water being loaded onto that great height of 16 meters. You can well imagine the kind of percolation it would be having to the soil below. All the 4 sides of that, the villages which were there, and the major one being Kokrana, because that's what we were concerned with, they were having problems of this fly ash toxic laden water oozing from their floors because of the differential head that had been created. There were a number of issues with it. I can't explain everything, but all in all, at the end of it, the villagers of village Kokrana, they were being asked to vacate that village. There was no solution to it. It was then that we realized the drawbacks or the cost and in terms of environmental quality of power generation. So something that we are not normally introduced to. So through this workshop, if there is a scope, I would like to stress upon this point that when we are generating power, we must also see that at what cost we are producing it. Cost not in terms of the tangible cost not in terms of only rupees and naya paisa, but also in terms of the quality of life that goes with it. And that single example of PTPS, I think now it's Amod will be able to tell us better what is the present status of that. But most of the power generation, it had come through thermal power stations. Why? Because the gestation period was very small. You could immediately set it in motion. The power generation through other means, the hydropower where India has a lot of potential, again suffers from the major problem of environmental degradation. Long back, of course, I read in literature, being a civil engineering student, that we are able to harness only 2% of the hydropower that could have been harnessed. Thereafter, of course, a lot of changes have taken place. We have moved far ahead in that direction, but nevertheless, Himachal, which has been the forerunner of power generation in the hydro sector, it is suffering from environmental problems. Forests are being cut on account of power generation for this. And there are, of course, as I said, other reasons and other issues which need to be tackled with it. So I believe the 2 of the 3 major requirements of our future, energy, clean environment, and strong computing tools, leave aside the strong computing tools, the other 2, they move together. Because I've always treated energy to be one of the 5 Panchtattva: earth, air, energy, space, and water. Energy being one of those important things, important parameters, needs to be given its due importance. Well, with those words, once again, I take this opportunity to welcome our chief guest, our delegates, resource persons, and all those who are attending this program here. I also wish this program all the very best, and I believe that after 3 days, when the participants go back, they have a feeling that the time they have spent in PEC has been worth their effort. Thank you very much.
Thank you so much, sir, for enlightening us with your motivational thought. We feel privileged to have such a distinguished guest, Professor S.P. Singh, Professor HAG, Electrical Engineering, IIT Roorkee, along with us. His specialization in the field of power electronics and electric drives, renewable energy system, and IoT applications. He obtained his master's and PhD in electrical engineering from the University of Roorkee, following which he has held various academic and research positions. One of the major area of research was in the area of design and planning of hydro plants. He has published extensively in reputed journals such as IEEE Transactions on Energy Conversion and Electric Power System Research, focusing on topics like self-excited induction generator, power system optimization, and power quality improvement. His expertise has been recognized through membership in prestigious organizations such as IEEE and in the Institute of Engineers India, where he served as fellow. It is my honor now to invite Professor S.P. Singh to address the audience.
Thank you. Chief guest, Mr. Manoj Tripathi, Chairman BBMB, Professor Bharat, Setia, Director, Professor Ritu Khanna, HOD, Professor Manohar Singh, and Dr. Ajay Kumar, Coordinator of the course. So, and distinguished professor and the distinguished professors and the participants available in the executives of the power utilities and the generating companies. So, feeling honored being present here to share my experience with the hydropower stations. So initially I have spent more than 2 decades in the design, investigation, planning, commissioning and testing of the hydropower station. So as I involved in the sector, I can tell you that there is application of all branches of the science and the engineering in the development of the hydropower projects. Moreover, mathematics actually the key of the science. So everybody need to know the mathematics. Without mathematics, nobody can understand the science. So here I can tell you the certain challenges about the say when we plan a hydropower station. And after when we plan and say commission the power station and during the operation also. So few of the challenges I can tell you, say regarding site identification. Site identification is important. What is the potential available? How many turbine you are going to select, and what kind of the turbine you are going to select, and what is the basis of the selection of the turbine. So normally it must be based on the generation cost. And then financial analysis is much more important. And say once you are planning a project, you have to know NPV and IRR. So IRR will help you, say, in taking the loan from the certain organizations. And what kind of the finance you are available, say from the government or from the private sector or the equity based and the environment clearance. And overall, once we are designing a plant, we have to have it has inherent self-regulation. So suppose somebody want to discuss, I will tell you later what is the inherent self-regulation of the plant. So nowadays we are going for the automatic operation of the plant. Just to switch on you just make a push button, the plant will start on automatically, and it will achieve a rated speed, and it will be connected to the grid. Again, when the plant is commissioned, there are the certain issues with the services. Sales after services. The problem is the service of the exciting system is not available.
And the most important problem, the part load operation. So part load operation I can discuss you in detail. So if there is efficiency, when you are operating the system and the part load, so efficiency optimization is important. And how we are going to get it, we can discuss in detail later. Not only that, they are old power stations. So they need to refurbish them and enhance their capacity. So let me give you the example how we can enhance the capacity of the turbine. Say by putting a runner of high specific speed. So we can enhance the capacity of the same turbine in the same frame. Similarly, in case of the old generator, we can have a conductor of the higher cross-section area with to enhance its capacity and having the better insulation. And old power stations, suppose there is, let me take an example of Sidra Brown, where you can see the old type of the mechanical governors are available. Now for the electromechanical governors are there, and PID governors, most of the digital governors are there. And moreover, say from the electrical engineering point of view, old panels, control panels are not available in the new power plant. All digital governors are available. And the most problem, one of the most important problem is the failure of the excitation system. Once there is a failure, the spare parts are not available. And this is the most important problem. And I will let you know how we can deal with this problem. And in the last, now we are not only the big hydro, we are planning, not only planning, we are harnessing the power from the low head schemes. So just to optimize the cost, where we are using pump as a turbine, machine as a generator, motor as a generator. So every machine can work as a motor as well as a generator. And it interfacing with the grid. And their control system, how we are going to control the frequency and the voltage, voltage, and they are interfacing with the grid. So this is all about, we will discuss in the coming lecture. So thank you.
Thank you so much, sir. We are honored to have a distinguished guest, Engineer Manoj Tripathi, amongst us. He is a mechanical engineer who took over as chairman of BBMB in September 2023. He holds an MBA Finance degree and a certificate in project management. He has more than 28 years of experience, mostly devoted to the hydropower sector. He was an officer of Central Power Engineering Service before joining BBMB. He served as Chief Engineer Hydro Project Monitoring at the Central Electricity Authority, Ministry of Power. He also held the position of Part-Time Director at JKS PDC. As Chief Engineer HPM at CEA, he was responsible for expediting the process and tackling issues of 42 under-construction hydro projects totaling 18,033 megawatt across the country. Additionally, he oversaw 3 intergovernmental CPSU projects totaling 3,120 megawatt in Bhutan and Nepal. He has also worked in various reputed organizations such as NHPC Limited, Mangetku Hydro Project Authority Bhutan, and IFFCO. He has visited over 50 hydro projects across India and abroad for matters related to project monitoring, resolution of issues, and etc. Now I request Engineer Manoj Tripathi to address the delegates.
First of all, thank you for introducing me. Our Honorable Director of Punjab Engineering College, Professor Baldev Setia, Professor S.P. Singh from IIT Roorkee, the Head of Department of the Electrical Engineering from Punjab Engineering College, and our professor Dr. Manohar Singh from Punjab Engineering College. First of all, I would like to congratulate Punjab Engineering College for carrying out such a wonderful seminar, which is need of the hour. When we are moving, earlier basically we were dependent on the conventional sources of energy, wherein we had only two sources. One was the hydro, one was the thermal. Thermal was predominant, and hydro has been developing over the years. So now when we are moving towards the renewable sector of the energy, so that's the need of the hour, and I congratulate Punjab Engineering College for taking the initiative of conducting such a workshop, and it's a 3 days program. So first of all I wish them all the best wishes for this program. This is very much relevant, as I already told, that this is very much relevant about the present scenario, what the present scenario is going, and there is a lot of new things which is coming. One of the new things which is coming is the green hydrogen. Some pilot projects are being undergoing at IIT Roorkee. I have seen in TSDC also they have installed a pilot green hydrogen project. And when we are moving towards the green hydrogen projects, then we are also talking about the uses of the green hydrogen. Like one of the uses which is now contemplated is in use in transportation. So that aspect will give us a cleaner transportation mechanism, especially when you go to Delhi or maybe Chandigarh. You see the level of pollution. So that level of pollution can be controlled by using the use of green hydrogen. But it is in the nascent stage. Now we have the academia here present. We have the other technical institutes here. We have the utilities here. So all must think of how to move ahead in this direction for e-mobility, or maybe say use of this green hydrogen in the case of producing urea. Because in the case of production of urea, this hydrogen is used very much. Being all the stakeholders present, so I think that will be a very good seminar here. So one thing I would like to advise, that when we are doing such sort of workshop, so let there be a two-way interaction. Normally what happens, the speaker speaks and the audience sits. So it's a sort of boring discussion because they are just listeners only. So whatever be your queries, maybe to me, maybe to the other speakers. So I would like that you hold a two-way discussion, not a single way, just a lecture what's going in normally college. So it's better to have a two-way discussion. You can. I was saying that there is one panel discussion which is to be held tomorrow, I think. So that panel discussion, I think you can add on one more panel discussion on some relevant topic, or a brainstorming session on some subject. So since many of the research institutes, educational institutes, power utilities, they are present here. So and each is having a different level of expertise. Basically, when we are talking about expertise, maybe the power utilities, they may have a practical understanding of what's happening. Research institutes, they may be having some other sort of expertise. So that will help in creating a win-win situation for both the utilities as well as the technical institutes. And this combination of academia and the public utilities is a very good combination, because whatever the public utilities are doing, they need to move forward. They need to move forward in some research direction and newer things. So for that purpose, the training, this academia as well as the research institution, they are of very much help. Now I am from BBMB, so you haven't kept a site visit, but next time what I propose that you keep a site visit of the Bhakra Dam. And normally I am allowing all the basically training institutes what's happening, because NPTI is one training institute near to Nangal. So normally we are allowing all the people, all the technical officers those who wish to see the Bhakra Dam. Bhakra Dam was built in from the year 48 till 63. It was the highest dam at that point of time. It's a 225-meter high dam. And still it's the number 2 in India. Number 1 is Teri Dam as of now, but number 2 is still Bhakra Dam. And if you talk of concrete gravity dams, it's still in the top 10 in the world. At that point of time, it was the highest dam in the world also. Regarding BBMB and the hydropower sector, I would like to say that when we are talking about, when Director PC, Professor Baldev Sethi, was talking about the tangible and the intangible benefits. When we talk of hydropower sector, especially BBMB, we are running the multi-purpose projects. These multi-purpose projects have multiple benefits. One of the major benefits is irrigation water, drinking water, and another aspect is the cushioning of the floods. What the floods is coming, we are cushioning it in our dams. So we are operating one of the largest, two of the largest dams in India. One is the Bhagra Dam, second is the Pong Dam, and their storage is one of the highest in India. It comes under the top 5-6 reservoirs in India. So what we are doing, we are storing this water and providing continuously to our stakeholders. So our stakeholders include water as well as power to our stakeholders. Stakeholders are the four states consisting of Himachal Pradesh, Punjab, Rajasthan and Haryana. And the utilities there are present, so you are also stakeholders and owners also, we can say that, because the state governments, there were only two states at that point of time, Punjab and Rajasthan. So they have put in the money and made that project, Bhagla Nangal as well as the other projects. Other intangible benefits when we talk of these type of multi-purpose projects, when you are talking about multi-purpose projects, it increases the water table. Normally what's happening, the water table is diminishing in many of the districts, it's increasing the water table. Recently I had been to Jaisalmer where the water of this Bhakra, our Pong is being diverted to the Harike barrage. From Harike it's going to Jaisalmer also. So we are seeing that we are able to irrigate the desert also, and you would not believe, I think those who have went there, you can see on both sides of the canal, you won't imagine that we are in a desert somewhere. It's totally lush green there on both sides of the canal, in the Gandhi Canal, and it's the longest canal in India. So that sort of effect this multi-purpose projects have on the areas. If we talk of irrigated area, we are providing irrigation to almost 8% of the irrigated area of the country. In terms of lakh of acres, we talk of, it's 135 lakh acres total what we are irrigating. We are storing around 34 BCM of water, 34,000 million cubic meter of water in our dams, and providing it continuously to our stakeholders. Regarding other aspects, when we talk about what this power aspect, then power also, we are producing around 10,000 to 12,000 million unit of power every year. And when we talk of in terms of installed capacity, then we are the third largest hydro producer in the country. The first is NHPC, somewhere around 6,000, then KPCL, and third largest is BBMB. We are at 2954 megawatt. So power, water, and the intangible benefits. Intangible benefits, what I talked is only a limited aspect. When we talk about the under construction projects, what hydro projects are going on, there are many intangible benefits, like it's providing the maximum amount of jobs to the locals. When we talk of Bhagra Dam, we had three major dams which were at construction during the 40s, 50s and 60s. So at that point of time, we were providing employment to around 30,000 to 40,000 people in each of the projects. Bhakra was employing around 30 to 40,000. Then Sundar Nagar, we have a river interlinking project also, wherein we are diverting water from Beas to the surplus water of Beas to the surplus. There also, that's the largest and the first river interlinking project, wherein we provided employment there also to 30 to 40,000 people. And in case of Pong project, that's also multi-purpose project, we provided employment to around 30 to 40,000 people. So you see the effect of itself, a multiplier effect. You are promoting the cement industries, lot of cement goes into the construction of the dams. Then lot of steel is required in that. So it's having these projects are having a multiplier effect on the economy. And moving in this direction, because BBMB has created this infrastructure way back in 50s, 60s and 70s. First of all, projects were Kotla and Yanguwal that were commissioned somewhere around mid-50s, 53. So after that, what we have done, we have become stagnant, because BBMB was made a body for operation and maintenance. During the recent years, we have got a mandate from our board to move ahead for the new projects. Now we are moving for the new projects. One of the challenges nowadays for the grid is, because as per our commitments to the global world, we have committed that we will be going for 500 gigawatt of renewable energy. That mainly consists of solar and wind. So for integrating all those renewable energy, we are moving towards, because in northern India we are operating one of the largest reservoirs in the world. So we have a good potential of pump storage also in our reservoirs. The total, we have identified 8 sites in our total Bhakra in the Pong Dam, and that total comes to around 13,000 megawatts. So we are planning to make 8 pump storage projects totaling to around 30,000 megawatts. Moving ahead, we are going for the DPR preparation of one of the first projects shortly. So that will help in providing the peaking energy. What it will help in addressing to the peaking energy shortages in the country because you will be getting the solar and the wind during the day, and during the night we will be pumping those water during the day and using it as a generation during the night hours. So that aspect we have covered. We have also moved towards the renewable energy. Our organization is a 100% green organization. We have only hydropower and a rooftop of around 4 megawatt at present, and we are also constructing 44.5 megawatt of floating and ground mounted solar stations also. Our 15 megawatt floating solar at the Nangal Pond has started construction, and that's the largest floating solar in the northern part of India. We have one at Chandigarh also, that's a smaller one, I think 1 or 2 megawatt. So that will be the largest, and that will be the first floating solar which is on a flowing river. It's this in Nangal Pond is very less storage, so it's a sort of flowing water. So that will be a testing experience also for our company. We can say Hartech is our basically who's executing their project. That will be a testing ground for that company also. That is the first project on a flowing water. So that aspect is also. Then we have potential for floating solar in the Bharat and Pong, but still because the fluctuation of water in our Bhakra and Pong reservoir is quite high. So we need to wait for the technology to come in wherein that level difference can be catered by that anchoring and the mooring mechanism which is provided in the floating solar. So that's all about BBMB. Regarding the challenges in the power sector, we can say that in the power sector it's normally divided into the generation, then the transmission and the distribution sector. When we talk about the generation sector, we see that today we are at around 4,28,000 megawatts of installed capacity. So during independence, we had only 1362 megawatt at that point of time for 1947. At that point of time, our per capita consumption was only 16 units per capita. And in the year 2000, we moved close to 1 lakh megawatt of power, and the per capita increased to 500 units. As of now, we see we are at 4,28,000 megawatt, and our per capita is around now 1,400 units of electricity. Though we are much comfortable when we compare it to the independence or maybe to last 25 years, because we have had in last 25 years we are seeing we are adding around more than 3 lakh of megawatt in terms of installed capacity. But when we compare in the world, so in the developed countries, if you see most of the developed countries, US, Canada, there the per capita consumption is more than 10,000 units per year. And the world average, if you see, it's also close to 3,000 units. So we are lagging in that aspect. But we have moved quite ahead, and we have done a very good job in the power sector in terms of containing the peaking as well as the energy shortages. Now that challenge has come because of the integration of the renewable energy. Most of the new capacity that's coming from either the solar or the wind. So that integration aspect is there, and for that we are also going for the pumped storage to cater to it, and we are also going for the solar and the solar projects in our geographical area. Now regarding penetration of renewables and solar. Balancing PSPs, they are coming in a large way. We are also going for it. Apart from this, many private developers as well as CPSUs, they are also going for it. At present in Central Electricity Authority, they are having DPR of more than 40,000 megawatt for the pumped storage projects which are going to come in the near future. One of the challenges also is forecasting solar and wind generation. As we are having more solar and wind, so that fluctuation factor is there. So that forecasting mechanism needs to be strengthened so as to cater to the fluctuating demands of solar and wind, fluctuating energy. That's another aspect which can talk about what's going in the country and what we need to see. Then another aspect of this penetration of renewable is flexible operation of thermal power plants and increasing the ramp rate in the thermal power plants, and the effect of these factors in the thermal power plants, because thermal power plants are designed to run on 24/7 basis as a baseless station, and when there is the penetration of the renewable solar will come, so in the daytime they have to run at a minimum technical load, so that will having an effect on the thermal power plants, so that also can be deliberated in this session. So these are the challenges of penetration, but apart from challenges, we have a lot of opportunities exist in using that green energy in making green hydrogen and using it in transportation industry, using it in making ammonia. Like I started my career with IFCO, so there we used to burn that what's called that it's sort of petrol sort of thing, something we used to burn it and get hydrogen and this all, and it was not a very constructive type of thing. Later on the fertilizer industry they shifted to natural gas. So now when this solar penetration will increase, so what will happen? We will have a lot of solar energy during the day, surplus solar energy during the day, it can be used for the electrolysis of water, and using that we can go for green ammonia using that particular source of energy. We use that particular green ammonia because that hydrogen created will be a green hydrogen. So that's one aspect. That's an opportunity for the industry also. The thermal, if you see the thermal power sector, the challenges are implementation of the new environment norms. Then flexible operation is steep ramping, what I have talked about, these are the challenges. Then because of these challenges, you will be having a low PLF. Then shortage of natural gas and the high price of natural gas, that's also a challenge in the thermal plants which are run on that natural gases. In the hydro sector, that's the most lucrative sector if you see, because when you are making a hydro project, it's not for 25 years as for solar, as for wind. You are making a hydro project, it's basically on a perpetual basis. You see, you have dams which have been constructed centuries ago and they are still working. Like our Bhakra dam, it's designed also for, our reservoir is designed for 400 years. So that's a challenge, because when we are talking of multi-purpose projects, so that's a challenge for us to control the siltation, because ultimately what will happen in storage projects, what happens is slowly the silt encroaches upon your live storage. So that's a challenge for us, and for that challenge we have a number of initiatives we have taken up, but ultimately it will be filled up. It's no technology is available that wherein you can control, you can just decrease the rate of siltation or you can take out some of the silt from it, but there are no ways to control that. So that's also a challenge for us also, because ultimately the cost of water is much more than the cost of electricity. Without electricity you can do something, but without water nobody can do anything, because once say light goes in our house, if the climate is okay like in February, you won't mind except that if your phone battery is low, maybe you will mind that the messages are not coming and we are out of connectivity. But if water is not there one day, so it's a very bad situation in our houses also, and we think of shifting for 1 or 2 days to some other place. It happens in Delhi also. We are facing some situations sometimes in Delhi also. I don't know about Chandigarh. I had been to Chandigarh recently only 4 months back. So water, basically we are a water provider also apart from that. So that's a major aspect of BVMB. Regarding hydro sector, because I had worked only in the hydro sector, I had been in NHPC, I had been in Bhutan also projects. I had been monitoring almost all the projects in the country. Apart from country, we have been monitoring projects in the neighboring countries, Nepal, Bhutan also, which have been built by Indian resistance. So the challenges are manifold, and one of the major challenges is the geological surprises or poor geology in the Himalayas. So that's the major challenge in the hydropower sector, which all the developers are facing. We had also faced when our construction was going on, and we will also face in our new upcoming KSPs. But nowadays, technology for better geological investigation, geotechnical as well as geophysical investigations, they are there. So that unsanitary aspect is reduced nowadays compared to what it had been decades ago. So that aspect we can cover it better. Gestation period is quite high, and one of the major challenges what we are seeing, that non-signing of PPA. So earlier it used to be a very much concern for those projects who get the project commission, but they hadn't got a PPA signed. So that PPA now there is a comfortable situation, because in the grid, if you see the year 2021 in the Indian exchange, if you see Indian Power Exchange, the prices of electricity were around hovering around 2 rupees per unit. But now if you see the peaking price of electricity, it's around almost 8 or 9 rupees. So now that even some of the hydro projects, even though they are not having the PPA, but they are not facing a hard time, because they are selling in the exchange and getting good prices. But at one point of time, they were facing a hard challenges because the average tariff of electricity from hydro, what it comes in the recent projects, it had been in the range of more than 5 rupees per unit. It had been in the range of 10 rupees in some of the projects, recently commissioned projects also. And if you compare it with the tariff of solar or wind, so it's quite high, almost double than that of solar or wind. Even thermal also, it comes in the range 3 to 4 rupees or maximum 4.5 rupees. So that challenge is for the hydro sector, but I've been in the hydro sector. I know the advantages, tangible as well as intangible benefits. So what I advise for the utilities that you go for the hydro sector. It has a longer life. You don't compare it like the life of hydro is quite different. Even if you are making a normal project, also its life will be 100 years for the civil components. And after 40 years, you can go for the R&M. We had also gone for the R&M of Bhakra once. And after R&M, we have also increased. We have also gone for the operating also. That now the units are operated also. Regarding the transmission sector, I would say that right of the way issues for the new lines, that's a major challenge, because especially in the hilly region, those from Himachal, I think they must be knowing that they are facing a hard time in this. Even the hydro sector, forest clearance is a very tough job, because one of our projects, 42 megawatt Buggy, our forest clearance is also underway since the last 1 or 2 years. So we are also pushing it that forest clearance is a issue which is relevant to all the sectors where the forest land is there. Then transmission corridor for RE, because a lot of RE is coming and that's a status here and there. So that transmission green corridor, that's also an aspect of challenge in the power sector. Capacity utilization of transmission sector, because the solar and the wind, the transmission lines created for those solar projects, that will not be utilized 24/7 basis, unlike in the case of the thermal power sector. So that's a challenge in the transmission sector. Our honorable PM, he had given the slogan, "One sun, one word, one grid." So that concept of transnational electricity grid supplying solar power across the continent, that's a good initiative being taken by Ministry of Power. And I think it will be helping in addressing the temporal differences between when solar is there, say in Singapore, so we won't have the solar at that point of time, so that power can be transmitted from the other regions of the world to India, from India to the other parts of the world. So that equitable distribution of solar power, that peaking shortage, we can cater to it. So that's a new concept, but for that transmission is a major thing. That transmission, how to develop such transmission corridors for such amount of this, that's a challenge there. But that's a very good initiative. So these are the challenges in the transmission sector. Regarding the distribution sector, if you talk about the distribution sector, there the key indicators of any DISCOM performance are the AT&C losses and the ACS-AR gap. So if we talk of the weakest link, so weakest link is the AT&C losses. I was reading somewhere yesterday. It is around 17% for financial year 22 for the DISCOMs all over the India. And the ACS average cost of supply and average realization revenue, there the gap is around 0.22 to 22 paisa per unit for the financial year 22. So that's a challenge in the distribution sector. Most of the distribution DISCOMs, they are running in loss. So that's a challenge, how to cater, how to price the price of electricity, how to give the subsidy, how to get back the amount of subsidy that's given. So that all are the challenges in the DISCOMs. And that's presently viability point of view, that's distribution sector, that's the weakest link, what I could find it out. Because generation sector, more or less, you are getting the tariff. Transmission sector also, you are getting somewhat tariff. But in this DISCOM sector, that's the weakest link, where I think people, officers from DISCOMs must also be present, so they can ponder over these issues. So I would not like to take much time, and we can have the session start. And wishing all the participants the best wishes. And as already advised, if you go for a brainstorming session, I think that will be a better option. Let's have a two-way interaction, because nowadays that we can say climate, not climate change, but the change is there. So after lunch, normally it brings a boring long lecture. So that aspect we can cover it in our. I think that we keep it two-way interaction. Two-way interaction is better than a single-way interaction. So with best wishes, Jai Hind, and best wishes to all. Thank you.
Thank you so much, sir, for your insight on green hydrogen and the hydrogen projects as a sustainable energy source and further discussing the challenges and opportunities in the power sector. Thank you, sir. Now I request Professor Baldev Sethia, Director PEC, to felicitate Engineer Manoj Tripathi, Chairman BBMB, with a token of gratitude. Now I request Professor Rintu Khanna, Head Electrical Engineering Department, to felicitate Professor Baldev Sethia, Director PEC, with a token of gratitude. Now may I request Professor Manohar Singh, Workshop Coordinator, and Professor Ajay Kumar, the Co-Coordinators, to felicitate Professor S.P. Singh from IIT Roorkee with a token of gratitude. Thank you, sir. An attitude of gratitude is not only the greatest of virtues, but the parent of all others. It is a privilege and great joy for us to extend a vote of thanks to all those who have contributed in one way or the other to make this event a grand success. Now I call upon Dr. Ajay Kumar, the workshop co-coordinator, to deliver the vote of thanks.
Good morning everyone present over here. On behalf of Electrical Engineering Department, I am glad to be standing here to express vote of thanks. Let me begin by expressing my sincere gratitude to the esteemed chief guest of the event, Sri Manoj Tripathi ji, Chairman BBMB, for sparing time out of his busy schedule and gracing the occasion with his presence. Your presence here today is of great significance to us, sir. I would like to extend my heartfelt gratitude to our Honorable Director, Professor Baldev Sethia, for his continuous support, guidance and motivation. His thoughts and actions have truly inspired the family of the PEC Chandigarh. I am thankful to the Deputy Director, all the Deans, HODs and the faculty members who kindly consented to our invitation and graced the occasion with their presence. They have always been generous with their time and unconditional support when their faculty members need them. I would like to thank Professor Rintu Khanna, Head Electrical Engineering Department, for all her efforts in organizing this particular workshop. An event like this cannot happen overnight, you all know. The wheel started rolling months ago. I would like to thank Dr. Manohar Singh, the workshop coordinator, for his efforts in organizing this event. I am sure it will be an incredible event in the field of power sector for Viksit Bharat at 2047. I would be failing in my duty if I did not thank my fellow faculty members and the staff members, without whom it would be very difficult to organize such a high-end workshop. My deep sense of gratitude to the Office of the Director, Accounts, Institute Guest House, Hostels, Media Cell, Photography Cell, and all the volunteers who made all the arrangements at their command to arrange a comfortable stay for the participants. Most importantly, I want to thank the delegates from the BBMB, HPGCL, PSPCL, Technical Education Department Haryana and other industries, and all the faculty members from the Academic Institute who made the event a memorable one. We sincerely hope that this event would turn up into great heights, great learning experience, and you will enjoy your time here in PEC Chandigarh. Finally, I would like to thank all of you who present here for making the time to be with us today and helping us in making this event a great success. Thank you everyone. Thank you.
The national anthem echoes a unity that binds us all, resonating with each and every soul. Sing it with pride, sing it with a smile, sing it with a deep sense of patriotism. Now I request all of you to rise for our national anthem. join for a group photograph in front of the administrative block, followed by tea in the Senate hall, in front of the Senate hall.